Welcome to Lesson 4, problem number 3, where we are solving absolute value inequalities. We are going to approach these very much like we approach absolute value equations. So we're going to need two different portions to the inequalities. In other words, let's just start with 3a, and we'll see exactly what I mean by that. So for number 3, we're going to start off with x minus 2 is less than or equal to 3. Then I'm going to leave a little space, and we're going to come back to that space in a minute. And I'm going to say x minus 2 is greater than or equal to negative 3. Just like with equations, we set the part of the equation that doesn't have the absolute value equal to a positive and negative version. We set it equal to the 3 and then the negative 3 of the side that doesn't have the absolute value. What's different is that we also flip the sign here. So we first start with less than or equal to, right there, and here we do greater than or equal to. So those are the two steps that we have to take when we set up the two inequalities. The next thing we have to do is to decide whether we have an and, because it might be that the word in between here should be an and, or maybe it should be an or. So I have a little clever way, I think it's clever at least, for you to know whether the word in right here in between those two inequalities should be and or. So think of if the absolute value portion right here, the absolute value, whatever's in the absolute value is less than some quantity, some number. If that's the case, think of less than, and I'm going to add the little d on there and get the word and. So when it's a less than, we're going to make it an and. Okay, let's maybe even think about this when we do the next one where I'm going to show you the or for problem 3b. Let's continue with this one though. We know this is an and because it's a less than sign. That original sign was a less than. Okay, so now we just solve these inequalities the way we've been doing them. We're going to add 2 to both sides. X is less than or equal to 5 and X, I'm going to add 2 to both sides, X is greater than or equal to negative 1. So that means because of the word and, the logic with the word and means that X has to be both less than or equal to 5 and greater than or equal to 1. So only the numbers in between negative 1 and 5 are going to be shaded. Solid circles at both because it's an or equal to, and we're done. Okay, let's look at the next one. First thing we have to do is isolate that absolute value. So I'm going to add 5 to both sides. So that's a plus 5 there, just a little bit messy. And we have 6 times the absolute value of, not sure why I wrote an H there, of X plus 4 is greater than or equal to 24. Divide both sides by 6. I'm not going to show all the work for that, but I'm dividing both sides of that inequality by 6. X plus 4 is greater than or equal to 24 divided by 6 is just 4. Okay, so now we are ready for our two inequalities. So I'm going to start those right up here. And because in this case, we have a greater, so what I'm going to do is I'm going to change a little bit of what we had over here. And I'm going to just kind of get rid of that. And we are going to redo that portion and say, okay, what if the absolute value portion is greater? So is greater than some number. So that's the case we have in B. So I'm going to think of greater, but I'm going to change that greater to greater. And this one is going to be an or because it is the absolute value is greater than or equal to. So greater. Okay, so now all we have to do, let's maybe work back down here now, and we're just going to say X plus 4 is greater than or equal to 4, or X plus 4 is less than or equal to negative 4. Notice the word or, notice that I flipped the less than or greater than sign and I use the opposite sign on the right. Okay, so now I'm just going to kind of do the work right here. So for this one, I'm not going to show that step, but I'm subtracting 4 from both sides. So we simply get X is greater than or equal to 0, or X is less than or equal to negative 8. So on my number line, I'm just simply going to go to 0 and solid circle again, and -8. And notice that this time, either x being greater than 0 works, or we'll also accept when x is less than or equal to -8. So with the or, in general, we tend to shade left and right. With the and, it tends to be in the middle. But there are, of course, exceptions to that we'll see with D and some other problems too. But you'll see the exception in D to just or always being left and right and being in the middle. Okay, let's go to C. Notice that this time I'm going to try to get rid of that fraction. So what I'm going to do is I'm going to multiply everything through by -2, which leaves me with 3, the absolute value of 3x minus 1. Because I'm multiplying through by a negative, I'm going to flip our sign and get a positive 10 on the right. So the absolute value of 3x minus 1 is greater than a positive 10. So now it's a greater than. We always determine whether it's an and or an or once we have the absolute value isolated on the left, which we do now, and it's a greater than sign, so it's greater. So we're going to basically just say 3x minus 1 is greater than 10, or 3x minus 1 is less than -10. Okay, that looks like a K, so I'm going to change that a little bit. 3x minus 1 is less than -10. Now it doesn't look so much like a K. All right, so now I'm going to do some work here, and I'm going to do a little bit of it without showing all the steps. I'm adding 1 to both sides, so 3x is greater than 11. Divide both sides by 3, and you're going to get x is greater than 11/3, or, this is the first part, or we're going to add 1, so we're going to get 3x is less than -9, x is less than -3. So in this case, we're going to go to -3. It's an open circle at -3, and we're going to shade to the left. And then we're going to go to 11/3. And 11/3 is somewhere between 3 and 4. It's 3 and 2/3. So I'm going to go a little closer to the 4 and make sure you can tell that's an open circle. And I'm going to shade to the right. Okay, I'm going to change the color just so you can see a little bit better here. Let's make this a blue color now. I think that will help. So in this case, it's a light bulb. So something unusual is going to happen here, but we're going to start by subtracting 3 from both sides. Being a light bulb problem, I'm not going to show all that work. I'm just taking 3 away from both sides, and my new inequality looks like this. Okay, now I'm going to divide both sides by 13. So when I divide both sides by 13, again, I'm not going to show all that work. I'm going to get a -1 on the left is less than the absolute value of x minus 3. Okay, so now I'm going to switch just to help us see it a little bit better. I'm going to say the absolute value of x minus 3 is greater than -1. Now, what I want you to see is that the step going from here to here, it's not like we changed the inequality. We just rewrote it with the x minus 3 on the left instead of the right. But either way, x minus 3 is greater than -1, exactly the same as -1 is less than the absolute value of x minus 3. So we didn't change anything except for the sides. And in order to do that, you have to flip the sign logically. All right, now we could do it the long way at this point and kind of say, oh, it's a greater than sign, so it's x minus 3 is greater than -1, and so forth. But what I want you to do at this point is to recognize that the absolute value of something being greater than -1 is always true. I already know that we would shade the whole number line. I already know the answer is all real numbers, or if you want to abbreviate it, all real numbers, or write it out. Every single number works. Now, if you don't see that, though, right off the bat, you could do it the long way and say x minus 3 is greater than -1, or x minus 3 is less than a positive 1, because we changed the sign when we moved to the right-hand inequality. Okay, we're going to add 3 to both sides, so we're basically going to get x is greater than 2. And remember, this is an or, so x is greater than 2, or x is less than 4. And when you think about that, if x is greater than 2 or x is less than 4, the entire number line gets shaded anyway. And we're done. Great job. Lots of tough problems there. Way to hang in there.